Hey everyone, welcome to compound interest. Alright, when we're talking about compound interest, this is the stuff you actually should know about because this will help you when you want to figure out how to make money or if you were to buy a house and what's your loan going to be and all that kind of stuff, because it deals with money over long periods of time is where it really helps out, like retirement or getting a 30-year mortgage on your house. So these are really going to be important things. So when we're talking about compound interest, really there's two types: compound continuous and compounding n times. Alright, so we'll talk about compound continuous in just a minute, but when we compound n times, here is the formula. Alright, so A equals P times 1 plus R over n to the nt. R is going to be the rate. We're going to write it as a decimal, so usually it's 3%, 5%, 10% written as a decimal. So you're not going to write 3 because that's going to throw off your numbers and you're going to get huge astronomical gains, or you have to pay a lot if you're having your own interest. N is the number of times it's going to be compounded. So is it compounded monthly, daily, yearly, quarterly, hourly? So how often does it get compounded per year? And then T is going to be for the number of years. The capital P stands for the principal, which is the starting amount, and A is the ending amount. Alright, so here we go. Let's just use that formula, and it's also down here below me in case you forgot what it is already or you didn't write it down. But find the ending amount. If the starting value was $10,000, the rate is 3%, and it's compounded yearly, quarterly, monthly for 10 years. So the first question I have for you is, which one will give you the most money of these three? Okay, well, we're going to find out. So the first thing we're going to do is we're going to do this compound yearly. So we're going to say A equals P is 10,000. And it's going to be 1 plus the rate is 0.03. Yearly is going to be over 1, and it's going to be for 10 years, so 1 times 10. Do I really have to put those ones in there? No, I don't. But just so you know, that's where all those numbers are coming from. All right, so if I just kind of put this right here, that seems really good. All right, so what I'm going to ask you, the second question, how much money is this? So what we're going to do is we are going to go to the calculator, and we are going to type in 10,000. 10. 1, 2, 3. Parentheses, it's going to be 1 plus 0.03, close my parentheses, and that's going to be to the 10th power, right? Let's just make sure I have this correct. 1 plus 0.3, 1 times 10. Okay, and we should get an answer of 13,439. So our amount is going to be 13,439 and 16 cents. Don't forget those cents. Alright, so that's how much it is if we compound it yearly. So now let's write this out if we're going to compound this quarterly. So I'm going to write it down here because I don't want to get too crunched in there. So we're going to say the amount is going to equal 10,000. 1 plus 0.03. Quarterly means how many times in a year is it going to be compounded? Well, 4, of course. And then it's going to be for 10 years, which is going to be 4 times 10, which is 40. Alright, so question number 3. How much is it if we compound it quarterly? So what we're going to do is let's go back here and we're going to write in 10,000 parentheses. And the parentheses are important because if you look, we have to do this whole thing and then to the 10th power. So if I just do times, it's going to mess some stuff up. So we don't really want to do that. So it's going to be 1 plus, and we have 0.03 divided by 4. And I can do that first because I'm going to do this division before addition, so that's fine. And I'm going to say to the 40th power. You say, oh man, that's way higher than to the 10th power, so we're going to multiply it more often, but this makes it a lot smaller. So we should end up with, it's 13,483. So the amount equals 13,483.49. Alright, so we compare those two. Which one's more? Well, this one's more by about 50 bucks, right? $50, $40, somewhere in there. So you're getting more money if it's compounded quarterly. So now what about monthly? So we'd say the amount equals 10,000, parentheses, 1 plus 0.03 over how many times is that going to be? That's right, it's going to be 12, and that's going to be to the 120th power. All right, so question number 4, how much is it for monthly? And we are going to say 10, 1, 2, 3, parentheses, 1 plus 0.03 divided by 12. Close my parentheses, to the 120th power. And we're going to get that to be the amount is going to equal $13,493.54. So $13,493.54. So is that more than the last one? Yes, it is, by about $10. So yearly to quarterly went up about $40 or $50. Quarterly to monthly went up about $10. So if we keep going to, let's say, from monthly to twice a month, to weekly, right, to daily, what we can do is we're going to, this compounding, which means it takes the money you have, gives you a little bit of that interest, and then puts it back in. And then the next month it would take whatever interest you earned, put that back in, and it's going to keep going. So that means it's just taking your money and giving you your interest earlier, right? This means you get your interest once a year. This means you get your interest 4 times a year. This one means you get your interest 12 times a year. So the more often you get your interest, the more money you're going to get. But you see how it's changing. It's diminishing by how much we're getting, because it's plus 40, right? Plus 40 here, and this is only plus 10. All right, so what we're going to do here is, if we keep on going and say, we're going to say monthly to daily to whatever, this actually becomes something that you'll see in calculus, but it kind of makes sense. Compound continuous, this is the other type, and you'll see this every once in a while. But compound continuous means what happens as the number of times we compound it goes to infinity. So we go yearly is 1, to monthly, which is 12, to weekly, which is 52, to daily, which is 365, to twice a day, to 4 times a day, to every hour, to every minute, to every second. Right? As we continuously compound this, those number of times get smaller and smaller and smaller. So if we go all the way down, so it's just continuously being compounded, we can say that's actually this specific formula. That the P stands for the exact same thing. Okay? And then we have this number E. And then we're going to have times R, sorry, not times, to the RT. Okay? So we have that. P is the exact same principle, right? R is still the rate, the percentage that you get. T is the time. E is just this number, and E is a number, and it's about 2.73. All right, so E is now a number. So if we go through this, this number that's in here eventually becomes about 2.73. All right, so now let's do, oh, sorry, didn't mean to move that on you. Let's now do the exact same thing, but let's use this compound continuous formula, also known as the PERT formula. So we're going to use PERT. Okay, so what's the principle? Principle, we're actually doing the exact same thing. So the principle is, we're going to say the amount equals 10,000, and it's going to be E to the RT. So it's going to be 0.03 times 10. Okay, and here's your last question. How much is that going to be? All right, well, let's plug it in. 10, 1, 2, 3, and then I can just do E. So if I go second, natural log, it's going to be E to the 0.03 times 10. So I can say 0.03 times 10 is going to be 0.3, right? With a decimal point over 1. And we should get 13,498. So if you look at that, man, that looks pretty close. So the amount is going to equal 13,498.59. So if we were to continuously shrink the number of the time frame for those compounding, the n value, if we make that 365 days, or once every a half day, or once every hour, as that number increases all the time, right? We increase the number of times that our value of n, it's going to end up being really close to this. So of the numbers, the maximum we can get out of $10,000 at 3% for 10 years is if we were to compound it continuous, and that would be this number, 13,498.59. A real quick thing just to look at, if we look at, let's see if I can find this here. Where is it at? There it is. If we go to here, here is, let's just zoom out a little bit. So here is about 16 years, 17 years for the compounding just yearly. That's how much you have. If we change it to quarterly, this is how much more money you'd get in 16 years. So that's quite a bit. If we go to monthly, see how this distance is decreasing. If we go to daily, see how it's just getting closer and closer and closer together. And then finally, if we compound continuous, it's pretty much the same as daily. So if you have the choice between daily and compound continuous, it's going to be about the same. But if you have a difference between compounded yearly and compounded daily, you're going to make a lot more money. All right? So there you go. That is just some stuff on compounding continuous functions.